type 1 interferon signal, no type 1 interferon inducible genes, I think it would be quite effective. And then it begs, well, how important is that signaling? Why did nature create that? Nature created that, so in theory, when E. coli was in the blood and the E. coli DNA interacted with an antibody and then was a chromatin-containing immune complex, but of E. coli, it triggered the TLR and must have some purpose. But a lot of things that may be a redundancy that isn't necessary. Hydroplaquenil, for example, hydroxychloroquine does not, we don't believe, have an infection signal, which would either argue that it doesn't hit TLR really hard, and that's probably the case. And if it does, it doesn't affect your infection. And I think in some of the patients who've had type 1 interferon elevations and inducible genes, type 1 interferon inducible gene positivity by heat maps or otherwise, have been on been on hydroxychloroquine, which would prove that drug, the magnitude of its effect is more modest. So anyway, like I say, I think the idea of getting TLR is sort of even upstream from inhibiting type 1 interferon itself or its receptor.
Yeah.
Go ahead.
And then another area of interest is around the proteasome or the immunoproteasome. Have you seen much around that?
Yeah, well, I mentioned that Velcade is bortezomib, and there are other proteasome inhibitors that are being studied in not only myeloma, but in autoimmune diseases. So I don't know. I'm not sure where they are. I can't remember seeing an abstract yet about it. But the idea of proteasome inhibition, I think, has merit for the reasons we talked about. It's going to more target the plasma cell, and you get the plasma cell that's involved in, again, my hierarchy is anti-DNA first, then APL's next, then Rowan law third, then after that it's, more random antibodies.
Right. And then, so one of the other things is looking at, genome-wide association studies to try and see in terms of the pathogenesis or the genetic pathogenesis of lupus. There seems that some of the mutations are actually in things like apoptotic clearance, DNases, RNases, and somewhat in the interferon signature as well. Do you see, this leads into interest in topics such as nets and netosis and neutrophils. Do you see the possibility for molecules that target these kind of pathways? Is there anything that you've seen in clinical trials that could be promising, and kind of what's your perspective on those targets?
Well, I trained in a place where the original mentor was a neutrophilologist, and sadly, even though he was a genius, he didn't describe nets. We just did aggregation and migration and aggregation. But obviously, netosis is important. But I'll take credit. I mentioned the neutrophil as a potential target. So now, whether you get at it through the C5a receptor, is one way of inhibiting neutrophils. So they neither aggregate or migrate or marginate or diapedese or phagocytize or produce extracellular traps. But then there are other ways of inhibiting extracellular traps. Nets may also be important in antiphospholipid syndrome. They certainly be important in lupus. I know adenosine has certain anti-inflammatory properties, and there are drugs that can increase adenosine and agonists of adenosine receptors, and they may inhibit traps, nets. So I'll have to leave it at that. But yeah, I do think the formation of netosis, again, has a biological purpose, but it may be redundant, and you can eliminate the ability of neutrophils to make